Greetings and good day to 14th INS participants. My name is Bob Mann, and I was the exploration manager at Lundine's Eagle Mine from 2013 until earlier in this year. And even though I'm now no longer with Eagle, they kindly allowed me to give this presentation. I also want to thank the organizers for allowing me to redeem myself after missing last week. Well, this talk is going to be a history of the discovery of Eagle and Eagle East deposits. And I'm going to try to condense an almost 30-year history into this 15 minutes. So while I have first-hand experience with Eagle East discovery, I was involved very peripherally at the discovery of Eagle. So I hope I don't leave anything important out or get something glaringly wrong as far as the earlier history is concerned. Eagle deposit is a very high-grade nickel-copper magmatic deposit. It was discovered by Kennecott, now Rio Tinto, in 2002. The project was purchased by Lundin Mining in 2013, and Eagle East is a very high-grade, similar deposit, satellite to Eagle, that was discovered after Lundin's purchase. This gives you an idea of the tons and grade. These numbers are a little old, but they haven't changed all that much, although Eagle East did get a little bigger. But you can see the grades there, 3.7 nickel, 3 copper for Eagle, and over 5% nickel for Eagle East and 4% copper as well. So these are juicy little plums in the ore deposit world. I've taken Jim Miller's map of the geology of the Mid-Continent Rift System, and you can see Eagle is down here just south of Lake Superior in the Upper Peninsula of Michigan, just northwest of the city of Marquette, where we were hoping to host everyone this year. So it is a Mid-Continent Rift System deposit. It's hosted in the siltstones of the Berga Basin, which you can just barely make out in this little finger of a syncline. Prior to the discovery of Eagle and Eagle East, there was very little research on the rocks that now are known to host the two deposits. There's a prominent outcrop around which the Eagle Mine has been developed called Eagle Rock, but in the old days, we all knew it as the Yellow Dog peridotite. And there was a master's thesis done on it in 1977, William Morris, Michigan State University, and in 79, a Michigan Geologic Survey paper in conjunction with the USGS by Klasner and others, including Bill Cannon. Hi, Bill, if you're out there. Morris concluded that based on the nickel content of olivines, it was unlikely that a deposit was nearby. However, Klasner and others looked at the ratio of trace copper and sulfur and decided that yes, there is potential for hosting a deposit. Jumping from the late 70s to the early 90s, Kennecott had an exploration office in the UP, looking for diamonds and then for zinc. And Dean Rossell, there in the middle of the picture, was charged with, among other things, mapping the Berga Basin. And he came upon a gravel pit, and as all glacial area working geologists know, you stop at gravel pits to do prospecting, and he found hundreds of mineralized magmatic boulders, some of which were very high grade. And you see our friend Ricardo Presnell, who is now passed on, in that picture. Here's an old airborne survey taken over Eagle Rock, yellow dog peridotite, which is this rightmost bullseye. A couple kilometers away is a very similar looking bullseye, and there's some very low and obscure outcrops, which Dean managed to find, and lo and behold, it was a similar rock type. So in 1995, Kennecott drilled a couple holes under that outcrop. And strangely enough, they didn't hit an intrusive. They hit only metasediments. As we'll see, they discovered that this intrusion is quite funnel-shaped and quite shallow on its western end. Well, jumping ahead again to 2001, they came back and drilled more holes around the yellow dog peridotite and did hit the intrusion and did find some mineralization, though nothing spectacular. They jumped over to the other airborne anomaly and drilled one hole and missed, and then drilled a second hole right into the guts of the anomaly and hit massive sulfide. 84 meters of massive sulfide at spectacular grades, as you can see. Interestingly enough, this cross-section shows gray as metasediments, green is a small bit of contact metamorphism, and red is massive sulfide. So they didn't actually hit any intrusive with this hole. Very interesting. Now, let's jump ahead to about 2000, probably 12, where we've drilled this thing out, and you can see the discovery hole there, that they did drill right into the guts of the main massive sulfide. The upper holes did hit the intrusive, that being purple, and semi-massive sulfide being the yellow. So that's pretty interesting. They drilled right through it and didn't hit peridotite. Well, in 2013, here is an aerial view of the model. These are kilometer grids here. Eagle has been well drilled out and is actually being mined or getting ready to be mined. Eagle East here, yellow dog peridotite outcrop on the west end, also drilled extensively, and they did find quite a bit of low-grade mineralization and a thin, patchy massive sulfide at the bottom, a meter or so thick and not very extensive. Note the absence of drilling off to the east here, and we'll look at a long section so we can see how these things look in profile in just a sec. Well, here's one of the models, and I like this one from Barnes or Geology Reviews because it really looks like what we actually found. And you're all very familiar with this and many other similar illustrations. But what it shows is that in terms of exploration, that you should be able to follow these things down. And this was shown at Voisey's Bay quite well. And that was our exploration model. If we have an intrusion that's mineralized, the right chemistry, and this might be Eagle East, that if we're able to trace the feeder conduit down, we might hit another pearl in that necklace. Well, this was Kennecott's theoretical exploration model, and this is a schematic cross-section of the Baraga Basin, a syncline filled mainly with metasediments, fine-grained siltstones, some greywackies, and a basal section of quartzite. And they thought that if Eagle's part of a conduit system, that maybe this basal section, which is in contact with the Archean gneisses below, might be a good place for a blowout based on the rheology contrast between these two rocks. So in 2013, Lundin took over they charged the exploration team, which included myself and Steve Beach, to not get too distracted and focus on looking as close to the mine development as we could. Well, we drilled the heck out of Eagle trying to find a feeder conduit, and we couldn't find one. We knew Eagle East was the right kinds of rock. It did have mineralization, and it was open to the east, although where it's open is very deep and relatively narrow. So we're talking 800 to 900 meters at this point. But that was really our only really good target within a couple kilometers of the mine development, so we decided to go for that. But in order to do that, to hit a relatively small target at relatively great depths, we decided to try the Devico drill system, which is able to steer the drill hole and still produce core. And the idea was to have a parent hole, either drill one or reoccupy a parent hole, and kick off the hole, bend the hole across the dike, back up, kick off again, and bend the hole across the dike. And we were hoping to get a few cuts of this dike without having to drill 800, 900,000 meter holes each time. And we're going to target the basement conduit, assuming, and here's a long section of the Eagle East intrusion. You can see its funnel shape. Assuming that it came up from a very steep angle, and that maybe down here at the basement contact we might get that blowout. So we were able to get 5 kickoffs, and you see them here, off of one parent hole, and we did reoccupy an existing hole that was left open. So we confirmed the presence of the dike, and that was good. We were able to follow it. But the last hole in this series was meant to go right down dip and cut across the dike, and it didn't hit any dike. But we did hit some nice massive sulfides, not real dense, not real high grade, but something that is unusually missing from the upper part of the Eagle East intrusion. So we thought we were onto something. So since that last hole missed, it kind of told us that it didn't dive down at a steep angle, and that maybe it turns horizontal. So we drilled a new parent hole. And as you can see, we've got quite a number of kickoffs, 15 in fact, from the one parent hole. And we did in fact keep hitting conduit with semi-massive sulfides over to the middle section here. And as we worked our way east, we started to hit massive sulfide. And there's a picture of some of it. And we had a press release in June of 2015 highlighting some of these intervals. And you can see why we were quite excited. Very high nickel copper tenors, higher than Eagle, 8% nickel, in some cases 8% nickel and 7% copper, and some fairly significant widths, 10 meters and 30 meters. So we had our discovery, and before and after, you can see that we had, in order to define the mineral resource, it took 8 parent holes and 77 intercepts to get enough information to calculate a mineral resource estimate. And this project is now in production. In 2016, they started the decline. We got the permit to go ahead and head over from Eagle, I think in 2017, and spent 2 years building an 8-kilometer combination spiral decline and straight decline, and went into production about a year ago. So I'd like to thank the symposium organizers. They've done just an awesome job at bringing this remote meeting together. Lundin Mining Corporation again for allowing me to give the presentation. Steve Beach, who was my cohort in the exploration department when we found Eagle East, and the entire Eagle exploration team, which was a great bunch of people to work with, and without whom we couldn't have gotten the resource drilled out in the time that we did. Also, Dean Russell, he let me use his picture, and who figured largely in developing magmatic deposit exploration of the mid-continent. I don't know if I have time for any questions, but I'm standing by.